And in today's episode, among other things, you'll see that global power is no longer in oil, it's in nanometers, and this dispute between the United States and China could change the future of humanity. NVIDIA has unveiled the first AI with human-like thinking, 10,000 units per year. Yes, we're going to take a look inside the first automated humanoid production line over there in China. Japan built a railway station that is 3D printed overnight, and that's with the help of a robot. Speaking of robots, Maximo from AES installed 100 megawatts of solar capacity. Let's break all that down and look at a few more technologies. Hello everyone, I'm Carlos Alves and you're watching Realidad Impresionante. There is something invisible that now underpins almost everything we think of as technology. Something smaller than a grain of sand, but that processes trillions of pieces of information per second. And without it, your phone and mine simply stop working. Fighter jets, no matter how modern they are, won't take off. And artificial intelligence simply ceases to exist. And that's exactly it. And that's why I'm saying that the world has entered the biggest technological race in history, the semiconductor war. For decades, global power was measured by oil, territory, or even military arsenal. But that has changed. Now, the true strength of a nation lies in nanometers. In fact, in the ability to produce transistors that are increasingly smaller, more efficient, and more powerful. Because whoever masters this scale masters the foundation of all modern technology. In 2026, this competition reached a completely different level. On one side, the United States, with a very clear strategy of technological containment. The goal is to prevent China from reaching the same level of industrial capability in the production of advanced chips. And this doesn't happen only through export bans on finished products, but mainly by blocking access to the tools that make these chips possible. At the center of all this is an extremely specific technology. Extreme ultraviolet lithography, known as EUV. Without these machines, which can cost more than $200 million each, it's simply impossible to produce chips below 7 nanometers on an industrial scale. And today, only one company in the entire world dominates this level of manufacturing. It's ASML, which is in the Netherlands. And that's exactly where the United States comes in. They operate a little differently than we might imagine. Using its geopolitical influence, Washington restricts China's access to these machines, thus creating, in practice, a technological ceiling. An invisible barrier that prevents Beijing from advancing in this frontier of artificial intelligence and high-performance computing. But the Chinese response didn't take long, and it didn't come only through technology. It came from the raw material behind all of this. China controls a significant portion of the critical minerals used in semiconductor manufacturing, such as gallium and germanium, which are essential for radar systems, satellites, and advanced components. And by restricting the export of these materials, Beijing began to directly pressure Western supply chains. At the same time, the country started a movement that is both internal and massive. Billions of dollars are being invested in creating a fully domestic supply chain, with companies like Semiconductor and Huawei exploring alternative paths, such as new lithography techniques and advanced chip stacking, trying in this way to get around the absence of EUV machines. And this completely changes the game, because it's no longer a linear dispute where one side simply blocks the other. And now it becomes a race of adaptation, innovation, and technological survival. And at the center of all this, there's an extremely sensitive point, Taiwan. And this small island, which some consider part of China, including the United States itself, has become, at the same time, the greatest strategic asset and the biggest risk for the global economy. Because if production is interrupted, the impact wouldn't be regional. It would be immediate and global. And that's why the United States, Japan, and other countries are rushing to build their own factories, trying to reduce this dependence before a possible conflict turns this vulnerability into a major crisis. And maybe this is the most profound change of all. The world is moving away from being an integrated global network and starting to fragment into technological blocks that are independent from each other. Each side is trying to ensure its own ability to produce, innovate, and conduct research. And in the end, this war isn't just about the chips. It's about who will set the rules in the 21st century. Because whoever controls this technology doesn't just control devices. They control intelligence, military power, and the pace of the next industrial revolution. At this moment, the future of humanity is literally being etched in silicon. Yeah, we talk a lot here about technology, about the future, about evolution, but there's something really interesting.
O nosso corpo humano, ele continua seguindo
Biological rules that are really old, and unfortunately one of them is baldness. Almost 1 in 3 men starts losing hair before the age of 30, and that was my case. If you follow me on Realidade Impressionante, you know I needed a hair transplant. But you don't have to let it get to that point because Manual's technology can help you. You can solve this without having to schedule an appointment, wait in lines, or even go from pharmacy to pharmacy looking for the medication. I know a lot of people do that. Here's how it works. Access the website using the link in the description. You answer a health questionnaire, the doctor evaluates your case, and if there's a recommendation, you receive a personalized prescription. The treatment is delivered directly to your home. Simple, discreet, and with no exposure, which many fear. It comes in a plain, unmarked box. And throughout the whole process, you also have clinical support via WhatsApp to answer your questions and adjust your treatment if needed. And the photos you're seeing on your screen, the before and after ones, are from real cases, real clients. And there's an important point here that I can't leave out. The treatment starts at about 1.70 per day using my coupon, which is impressive. You get a 40% discount on your first order, and you also get free shipping, see? So go ahead and access Manual's website through the link in the description. It's right down here. It's my link, and it's also in the pinned comment. The QR code is on your screen, so act quickly and follow my advice. Coming from someone who was also bald. NVIDIA announced a massive expansion of its AI ecosystem with a very clear goal: to take artificial intelligence off the screens and make it perceive our world. With this, it will be able to reason and act in physical environments. In case you haven't noted this yet, it could change everything. Because now we're not just talking about an AI that only responds, but about systems that perceive and understand the environment, make decisions, and act in real time. For autonomous vehicles, the company introduced Alpamile 1, a model capable of interpreting its surroundings and explaining its own decisions, something essential for systems that need to operate safely in our world. Along with that came AlpaKim, a simulation platform that allows these systems to be trained in extreme scenarios and situations that would hardly happen in traditional tests. But the main point here is the data. NVIDIA released massive datasets, including more than 1,700 hours of real driving and dozens of terabytes of sensor information, thus creating a foundation that allows artificial intelligence to learn from diverse, complex data. This was part of a larger movement. With models like Cosmo, Isaac Roach, and Nematron, the company is contributing to a unified artificial intelligence foundation, which can be applied to cars, robots, and physical systems in general. In practice, this represents an advance in so-called physical AI, systems that not only process information, but also need to deal with the real world, with unpredictability and continuous decisions. But isolated intelligence still has its limits. It needs reach, it needs presence, and it needs to be connected and distributed. And that's exactly where a new layer starts to emerge. China has started a 2-year commercial trial for satellite-based Internet of Things services, allowing companies to operate systems capable of connecting devices directly from space, without relying on towers, cables, or any terrestrial infrastructure. And this changes the equation, because we're not talking about internet for people, but internet for machines, sensors, and systems that need to operate in places where the traditional network simply doesn't reach easily. Sectors like logistics, agriculture, energy, maritime operations, and emergency response now have a new layer of connectivity, working even in remote or extreme environments. But the most important point isn't just about the technology, it's about the model. The participating companies need to build the entire chain, from the satellites to the operation and management systems, which makes this test much closer to a full market validation than just a simple experiment. And their goal is clear: to create a new industry with the potential to generate tens of billions. This initiative is part of a larger strategy to strengthen industrial internet and expand the commercial aerospace sector. But the impact goes far beyond the economy. Because by bringing connectivity to space, the dependence on physical infrastructure starts to disappear. And this completely changes the concept of network. Coverage stops being regional and becomes continuous and global. And this movement is directly linked to the advancement of so-called satellite megaconstellations, entire networks positioned in low orbit, capable of providing constant communication to any point on the planet, just as the United States has already done through Elon Musk's Starlink. In practice, this means that devices on land, at sea, and in the air become part of a single integrated network, operating without traditional limitations. And with a connection like this in production, China is now starting to expand its current pride and joy: humanoid robots. On March 29, 2026, an automated production line capable of manufacturing up to 10,000 humanoid robots per year went into operation in the Guangdong region. This is not just a technical breakthrough, but a structural shift in the industry. Because until then, most of these robots were still limited to small-scale production, almost handcrafted within controlled environments, of course. Not anymore. Now we're talking about a single factory delivering a complete humanoid every 30 minutes, operating with 24 precision assembly steps and 77 points of multidimensional inspection, which ensures not only speed, but also standardization and reliability at an industrial level. But what really changes the game here isn't just a number, it's a model. This assembly line was designed to be flexible, capable of switching between different types of robots without having to stop the entire operation. Their secret is using integrated autonomous vehicles and digital management systems that reorganize production in real time. This brings this process much closer to what we see in the automotive and electronics industries. Leju Robotics is responsible for the development and intelligence of the systems. Dongfeng Precision, on the other hand, handles large-scale robotic manufacturing. The competition is no longer about who has the most advanced robot. Now it's about who can produce more, faster, and at the lowest cost. Before leaving the factory, each unit goes through dozens of tests simulating real operating conditions. But of course, simulation is not reality, and the world outside the lab remains chaotic, dynamic, and full of variables that can't always be predicted. And according to recent projections by experts, the world could have billions of humanoid robots in the coming decades. Agabot is also making moves.
Vamos ver agora.
While some are preparing to create 10,000 humanoid robots every year, others have already reached that number. That's the case with Agabot, a company based in Shanghai, which has just reached the milestone of 10,000 humanoid robots produced. And what's most interesting is the speed of this evolution. It took almost 2 years for the company to produce its first 1,000 robots. Then they had another year to produce 5,000 humanoid robots. And now, just 3 months to produce another 5,000 robots, which shows an extremely aggressive acceleration in production capacity. This doesn't happen by chance. This kind of growth is only possible because the supply chain starts to consolidate and the processes stop being experimental and become industrial. And each stage of production starts to operate with real efficiency. The model responsible for marking this incredible moment is the Agabot A3, recently introduced as a bipedal platform. It has already demonstrated quite advanced physical capabilities, including complex movements that were previously restricted to highly controlled environments. Mass production is not just a matter of quantity. It is the main way to reduce costs. And that's exactly what can turn humanoid robots from something experimental into a viable solution for sectors like logistics, retail, and manufacturing. And when that scale meets real-world application, a shift starts to appear in our world, and things start working already, you see? A robot named Maximo, developed within the AES ecosystem, has just installed 100 megawatts of solar capacity in a single project in California, thus marking the transition of robotics from testing to real commercial operation. And in case you don't understand, let me tell you, this number isn't small. We're talking about a utility-scale project where any delay impacts the costs, schedule, and feasibility of the project. What makes this possible is the way the system operates. Maximo uses computer vision and artificial intelligence. It identifies the position, structure, and variations of the environment, being able to install solar modules with sub-millimeter precision, even under real conditions like dust, wind, and extreme lighting. And the most interesting thing is the level of automation. In full mode, the human operator simply starts the process, and the robot performs the entire installation. While in supervised mode, it positions the panels and humans only finish the fastening. In practice, this turns one of the most critical stages of construction into a standardizable and predictable process, and the numbers are starting to show the impact. The system is already able to install more than 1 module per minute, practically doubling productivity compared to traditional methods, that is, those done by humans alone. But what really changes here is not just the speed, it's the scale. The project evolved from a single robot to a coordinated fleet operated in parallel, showing that this type of technology can already work at the gigawatt level,
É a robótica deixando de ser apenas automação industrial
and starting to play a direct role in building our physical world, in critical sectors like energy, for example. And maybe the clearest sign of all this is in the way we start to build, because when machines begin to build the infrastructure, time is no longer a limitation. Focus on this next report and you'll understand what I'm talking about. Over there in Japan, wow, in Japan, an entire train station was practically built overnight, between the last train at night and the first train the next morning. In other words, it happened without interrupting the operation of the line. And this wasn't done with more workers, it was done with robots. The project used a combination of 3D printing and industrial automation, with technology from ABB, where the structural components were manufactured off-site beforehand and then brought in for assembly. And here's the most important point. The heavy work, as I mentioned, didn't happen on the construction site, it happened beforehand. An industrial robot was responsible for 3D printing the structures with high precision, thus ensuring that each piece arrived ready to be fitted, reducing adjustments during assembly to almost zero. Once everything arrived on site, it was no longer a construction process but an assembly job. The result was a complete station built in just a few hours, something that would traditionally take months to complete. The construction industry, which has always been one of the slowest industries to transform, is now beginning to adopt the same kind of logic we've already seen in manufacturing. Produce off-site, assemble quickly, and scale efficiently. Yeah, if you enjoyed this episode, my friend, go ahead and leave your like and make sure you're subscribed, all right? Oh, and don't forget to check out Manual, okay? You help me, and you help yourself too. You get 40% off free shipping, and that's on your first purchase, of course. Use the coupon Impressionante. Thanks for sticking with me. See you next time. Just click one of the 2 suggestions on your screen. Thank you, my dear. Thanks, bye. I'll be waiting for you there. Click and join me. Go on, click there. What are you waiting for? I'm waiting there, click there.